Alright guys, so this is unit 4, day 14. This should be done on Thursday for my calculus student. Thursday for calculus students. And Friday, your last day without me, that's going to be your study guide, study review for unit 4 test. But we're going to have Monday and probably Tuesday to review for that test. Okay? So let's begin on this lesson. So this lesson is all about tangent lines approximation. We done it, and you done it in the past, but we never really like called it a name before, and you never really like connected all the dots together. So we're gonna be tying in pretty much everything we've done in calculus all in this one lesson to approximate certain values. Okay, so we look at this first equation. So find the tangent line approximation of this, right, at that point. Okay, so we're going to be making a tangent line of this function using this point, right? This is your x, and that's your y. Okay? And then we're going to go from there. So a tangent line, what should pop out when you think of tangent line? You should think of that equation, y minus y1 equals mx minus x1. Okay, I know some of you got it, so good job to those of you who got it. If not, it's fine. You'll remember it eventually. So now this is our tangent line. Okay, now we need to start plugging in points. Here's our x, here's our y. They're given to us easy. So x is 0, right? We're still missing our m, and y is 1. Okay, just so you guys know, if they only gave us the x, how do we find our y1 value? Well, you plug in your x into the original equation, into our original. How do we find our m value? We plug in x into the, not the original, but the derivative. So what do you think we need to find right now? The derivative, okay? So f prime of x equal to, what happens to this one when you take the derivative? It goes to 0, but why? Because it is a constant, right? The derivative of sine is cosine of x. Perfect. Now we need to plug in 0. So f prime of 0 is equal to cosine of 0. Now what is cosine of 0? Think of your unit circle. I'm going to do it on the side right here. Right? So here's your unit circle. 0 is right here. What is that coordinate point? 1 comma 0. And what is cosine? Is that it? Is that our x or is that our y? Cosine is the x value, right? Sine is the y value. So cosine of 0 is 1. So this right here equals 1. So this is our tangent line approximation. Okay? Excuse me, I'm drinking Starbucks right now, so. This is our tangent line approximation. Sorry about the noise too, so that's our tangent line approximation. Now that we have this, now let's take a look at this next part. Is this approximating an over or under estimate? Well, in order to see this, we need to look at the graphing part. Okay, so just so we have a little bit of background knowledge, right? We're gonna be graphing this one, okay? But let's start simple. Let's first start with the function is equal to sine of x. So how does that function look like? Well, do you start at 0 or do you start at positive 1? Who remembers that from last year from pre-calc and geometry and algebra 1? Well, cosine of 0 is equal to 1, so that one starts at 1. Sine of 0 starts at 0, right? So we're starting right here, and then it's going to go up, right? So up, down, and so forth. Sorry about my line. I know it's supposed to be even. Okay? So that is our approximation, right? But now we have the function, or not, so f of x is equal to 1 plus sine of x. So what's the difference between these two? The plus 1. And what type of shift is that? Is that a horizontal shift or a vertical shift? That is a vertical shift. And that's shifting up what? Up 1. Okay? So we redraw the graph, right? Basically, it just shifts it up 1. So it's going to be the exact same graph. It just shifted up 1. Okay? Now, this approximation right here, that is actually this part. Let me get a different pen. That is this part right here. So at x equals 0 and y is equal to positive 1, we're drawing a tangent line right there. Okay? So this is our function. Okay? So the blue is our original f of x, and the orange is our tangent line. Okay? Just so you guys are aware. Okay? And that's pretty much the lesson. But if we go back to this question, is the approximation a overestimate or underestimate? Well, let's take a look at that. So I want you guys to think about it. This tangent line, that's what we're estimating. So, well, we're estimating this one, f of x. Okay? So if you look at that point, the tangent line touches that point at that one point. Now you look to the right of it, to the right side, the tangent line is over the function value. Can we see that? It's over. Because it's over, that means on the right side, the tangent line is going to be an overestimate of the function. Okay? So let's write that. So instead of writing that, let's just do one example. So if I'm trying to approximate x is equal to 0.01, okay? So that right there is to the right of 0. To the right of 0, right? That's to the right side. So what does that mean about our function, our tangent line? So if we're approximating that one, we can say that y minus 1 equals to 1, x minus 0 is n. So we said to the right of it, it's an overestimate. So is a overestimate. Pretty much done. But why? You want to put a reason to it. Why? Why is it considered an overestimate? Because the tangent line, because the tangent line is greater than the original function, than f of x, right? The tangent line is greater than the original f of x. Now let's do the reverse side, on the left side. How about x is equal to 0.01 but negative? So now we're not looking on the right side, we're looking at the left side. So you see how this function, the original function, it's over the tangent line, it's greater than the tangent line. So what does that mean? So, x is equal to negative 0.01. So that is to the left of 0. So what does that mean about the tangent line? So the tangent line is an what? Underestimate. Sorry guys, it's kind of hard to record, talk, and write at the same time. So the tangent line is an underestimate because the tangent line is less than the function. Done. Now, of course, guys, you guys can change the sentence around a little bit, but this is pretty much the gist of it. Okay? Because the tangent line on the right side is greater than the original function, it's an overestimate. And on the left side, because the tangent line is less than the original function, it is a underestimate. Okay, so let's flip the page and let's see if we can do the back. So this is a real life problem that mathematicians do in their head like all the time. Not really, but I sometimes do use it when I go to the grocery stores to like estimate different things. To be honest, math life. So let me see. All right. So the next one, we are approximating this value. That's what we're trying to approximate. The cube root of 127. Now in your head, you're thinking like, oh shit, how can we do that in our head, right? Well, we're gonna make a tangent line, okay? So it's basically saying to use that as a function, okay? So now we have our function equals cube root of x, okay? And then choose the perfect cube closest to that. So 127 closest perfect cube is what? A perfect cube, guys, is one number multiplied by itself 3 times. That's a perfect cube. Okay, so 5 times 5 is 25, times 5 again would be 125, right? So it would be 125. So our x value would be 125. Okay, now that we have our x value, so can we see how 125 is really close to 127? So we're going to be making a tangent line off of this value, and then we're going to be approximating using 127. Okay. So tangent line should ring a few bells. Tangent line, the equation y minus y1 equals minus x1. Okay. So we already have our x1 value, which is 125 minus x. We need our m, and we need our y1. So again, guys, how do we find our y1? We need to plug it into the original function. But what are we plugging in? We're plugging in 125. Okay. So f of 125 equals. So what is our function? Our function is this one right here, right? So we have the cube root of x. But what are we plugging for x? 125. And we already know that the cube root of 125 is 5. So y minus 5. Done. And then now, the m part. M, we need to plug in 125 into our what? Into our derivative. Okay? So, just so you guys are aware, right here, excuse me, we can rewrite this as x to the 1/3. Okay? Now, how do we take our derivative if we have a fraction on top? What rule is that? It's not the quotient rule, not the low-D-high rule. It's not the chain rule because there's only one function. We don't have a function inside of another function. It's going to be the power rule, the very first rule that we learned, the power rule, right? So we move that to the front and then subtract 1, right? So we have 1/3 x to the negative 2/3. Done. Now, how can we get rid of this negative? We need to move it to the bottom. So that's going to become 1 over, we still have that 3 on the bottom, but now we have x to the 2/3. Positive, right? Being multiplied. And then we can rewrite this function, going back to the radical form. This 3 will go to the outside, and this 2 will just be the squared part. Okay? So that is the same thing as saying 1 over 3, and then the cube root of x squared. So we can do it that way, or it is also equal. This square can actually go on the outside. So 3 x, and then all that will be on the squared. Okay, not the 3, only this part, only the inside of that function. Okay, and the reason why I'm showing you this right now, because technically Your other math teacher should have showed you this, but the reason why I'm showing you this right now is because we're going to be using this one right here. Okay, we're going to be using that one. So now we need to plug in f prime of what? Our x1 value, which is 125, right? So it's going to be, let me get a different mark. So it's going to be 1 over 3, and then we have the cube root of 125 squared. So cube root of 125 is 5. So 1 over 3 times 5 squared. 5 squared is 25 times 3 is 75. So 1 over 75. Done. That is our F1. 1 over 75. Okay. Now we have our tangent line. Okay. Now we can use it to approximate. Okay. Now we can use it to approximate. So now let's write our original function. So y minus 5 equals 1 over 75 x minus 125. Okay, that is our tangent line. Now we need to approximate. Now we need to approximate 127. And that value we're going to be plugging in into the x. Okay, so when you're approximating something, forget about the value that you're approximating, get a tangent line, and then at the very end, after you get your tangent line, then you plug in that number. Because we're using the tangent line to approximate the value that we're looking for. Okay, so plug it in, and then we solve it. Y is equal to 1 over 75. Instead of writing x, we're writing 127 minus 125, and then the plus 5. So just in case you guys are aware, I'm solving for y, so I move this to the other side, so that's the plus 5 part, and I'm changing the x to the 127. Now, in calculus, do we need to solve this? No, we can just leave it like that. Okay, and we're done. Okay, but just so you guys can see, right, if you use a calculator and you plug that value in, the approximation value, right, the approximation value is going to be 5.026666 and so forth. Okay, now just so you guys are aware, if you plug in the original value, this one, right, so the cube root of 127, right, on the calculator value is going to be 5.02656. Okay, you see how those values are extremely close? So we got a tangent line, plug in the value, and then we approximate it, right? So based off these two values, is the tangent line a overestimate or underestimate? Now we're answering this one. So this is our tangent line, and this is our approximation value. This is the real value, should we say. So is this, the tangent line, a overestimate or underestimate? The answer should have been, it's a overestimate, because here it's a 6 and here is a 5. Okay, so our tangent line is a overestimate. So now let's write our sentence. So y minus 5 is equal to 1 over 75 x minus 125. Okay, so that's our tangent line. Okay, so is this an over or underestimate? So the tangent line is an overestimate because, so what is the reason? The reason, because the tangent line is greater than original f of x. Done. Sorry. The tangent line is an overestimate because the tangent line is greater than the original f of x. Okay. How does this look like in a graphing point. Okay. So if you're to graph if you're to graph this equation, right, the function will go something like this, right? And if you go to that point, we draw a tangent line. It's going to go something like that. Okay, and we can clearly see that the tangent line is an overestimate of the original function. Okay, the tangent lines are over the original function. Okay. Don't worry, guys. I'm going to be explaining this more in person on Monday when I get back. Okay. Is everyone okay with this? Okay. And just to explain a little bit more, guys, just because a function is increasing doesn't mean that it's going to be an overestimate or underestimate. Okay. So we take a look at these two graphs. These are two examples. So we're already done with this problem. We already answered it. So we take a look at these two examples, right? If I have a function that goes something like this, right, and I draw a tangent line. So this is a tangent, and this is the original function, right? We can clearly see that the tangent is going to be an overestimate of the original function, right? But what if the function is still increasing, but I draw it like this? Now this is the original function, and then we draw a tangent line anywhere, right? So this tangent line is going to be a underestimate. Okay, so this is a overestimate, and this is a underestimate. Okay, so these are another two examples. You may use your calculators, but I want to see you guys do the actual tangent. Find the actual tangent. Okay, so now you guys can do the rest by yourself. This right here, right? This is our function. That's our point. So to make our tangent line, these right here, the t of x, that's going to be your tangent line approximations, right? You get your original, and then boom, now you can approximate these rest of the values. Okay, the f of x is your original function. So that one you're going to need to use your calculator and just plug them in right there. Okay, so f of x is your original function, and the t of x is your tangent line function. So get the values, right? Make your equation, get the values, and then you can see and compare to the original function to the tangent line approximation. Okay. All right, guys. I want to say I miss you a lot, and I will see you Monday. Okay. Thanks, guys.